In the first of this series of short videos, we suggested a new simple structure for a photon that will explain how it can appear massless but still be affected by gravity. We also discussed why the two particles comprising a photon always travel faster than light, despite light always appearing to travel at the speed of light in a vacuum. If you haven't watched this episode, please click on the link at the top of the screen. While you're in clicking mode, please click on the like button and subscribe to the channel to see more episodes. Thank you. In this video, we'll suggest how this simple particle could result in a whole spectrum of different wavelengths of electromagnetic radiation, EMR, and demonstrate different properties. In the first video, we saw an animation of energy transforming into an electron and positron, rotating around each other, describing a double helix that moves at the speed of light. You'll probably be aware that EMR is not just one frequency, but an enormous number of frequencies ranging from 10 to the power of 1 Hz, 10 cycles per second for radio waves, to 10 to the power of 26 Hz for gamma rays. In order to visualize this range, a radio wave cycling 10 times per second would cycle once in just less than 30,000 kilometers, whereas a gamma ray would cycle more than approximately 300,000 times per picometer. So how could one particle produce this wide range of frequencies? If the photon comprised a negatively charged electron and a positively charged positron, it becomes the newly christened binary particle. The force of attraction between the two particles should vary inversely as the square of distance separating the two particles. This should be in accordance with Coulomb's law. This means that if the distance between the two particles was halved 7 times, and the initial force required to keep them apart was equal to 2, the final force required would have to be 10 to the power of 38 times greater. The difference between the cycle rates, hertz, of radio waves and gamma rays is only 10 to the power of 25 different. This would at least provide the possibility for a single binary particle giving a range of rotations seen between the radio waves and gamma rays. This raises all sorts of questions. Two of the most interesting are: 1. Is there a correlation between the intensity of the energy in the source and the wavelength of light emitted? 2. Why would binary particles of different frequencies behave in different ways when contacting matter? Is there a correlation between energy intensity and wavelength of the photon produced? There is a definite correlation between heat of an object and the wavelength of EMR emitted. This is demonstrated easily by heating metal until it glows red-hot, infrared radiation, and emits infrared wavelengths from 10 micrometers to 100 micrometers. If heat is continually applied and the metal is white-hot, it emits light at shorter wavelengths, 560 nanometers to 580 nanometers. In general, the higher the energy input, the shorter the wavelengths emitted. The higher the rotation rate of the binary particle, the more energy the particle, pre-contact with matter, should contain. This means that the variable in the Newtonian equation for kinetic energy, E equals 1/2 mv squared, is the velocity v. In the equivalent Einstein equation, E equals mc squared, velocity is the constant c, and mass is variable. The second question is even more interesting. Before we look at the different wavelengths of EMR, we should understand that matter really isn't that solid. The nucleus of an atom is 100,000 times smaller than the orbit of the circling electrons. Or to put it another way, if the atomic nucleus was the size of a golf ball, the edge of the electron shell would be 1 kilometer away. So, lots of room. Let's split the photon spectrum into its major regions and discuss how a binary particle would behave when in contact with matter. 1. Radio waves. The distance between the electron and positron is at its greatest at this wavelength of EMR, and therefore the attraction, bond, between the negatively charged electron and the positively charged positron would be at its weakest. The binary particle would be rotating very slowly, reducing the possibility of it impacting with an electron or atomic nucleus. Metals give up their outer shell electrons, making them generally cationic. This might affect the weak bond between binary particles in radio waves, making it difficult for radio waves to pass through metals or water. It would not affect the passage of radio waves through non-conducting matter like bricks, etc. 2. Microwaves. When the idea of a rotating binary particle is applied to microwave radiation, we would expect that the higher rate of rotation as compared to radio waves. This would provide a greater chance of colliding with an electron, positively charged atomic nucleus, etc., and therefore restrict the possible penetration of a microwave when compared to a radio wave. Their increased rotation rate would increase the energy available when the binary particle self-annihilates. The bond between the electron and the positron would still be relatively weak, and therefore polar molecules such as water would disrupt the bond and release energy. Non-polar molecules would be more transparent to microwaves. 3. Infrared light. The increasing rotation rate of the binary particle increases the chance of collision or near contact with either a negative electron or positive atomic nucleus. 4. Visible light. Then, as EMR frequencies approach near visible light, a strange thing happens. The absorption of light by water suddenly decreases sharply. There is an odd relationship between water and its opacity to this part of the EMR spectrum. The molecular structure of liquid water is in debate, but the consensus of opinion seems to be that liquid water has a tetrahedral and chain structure, with emphasis on the tetrahedral structure. Water starts being more transparent to the EMR spectrum at about 10 micrometer wavelength and drops to minimum opacity in the visible light wavelengths. It seems as if the rotation of the binary particle and the structure of the water somehow facilitates an easier passage of these wavelengths through its structure. 5. Ultraviolet light. As this range of EMR increases in energy and as its wavelength shortens, its ability to penetrate water as the binary particle increases. The binary particle becomes more compact as the distance between the electron and positron shortens and the bond becomes stronger. Despite its increased rotation rate with a greater chance of colliding with either the negative electrons or positive nuclei, the overall effect is to reduce water's ability to absorb UV light as its wavelength shortens. 6. X-rays. As the wavelength of EMR continues to decrease, the distance of the electron and positron also decreases, the bond becomes stronger, and the velocity and energy in the binary particle increases. The smaller radius of rotation, E-, E+, the greater the chance of the particle not interacting with the atomic nucleus, nor electron boundary of the matter through which it's passing. Therefore, soft X-rays will penetrate 1/1,000,000th of a meter of water, whereas the more energetic hard X-rays can penetrate matter of thicknesses up to the equivalent of a few meters of water. No exact measurement was given, but will produce more energy when they self-annihilate. This is the reason they are useful in medicine, for seeing bones, but can be dangerous if cells are overexposed, producing changes in DNA that may result in cancer. 7. Gamma rays. Once more, the wavelength of EMR is reduced, the distance between the electron and positron is less than seen with X-rays, and the velocity of the two particles is higher. This results in gamma rays having higher energies when they self-annihilate. The closer proximity of the two particles, the less likely their contact with an electron or positively charged atomic nucleus, and therefore gamma rays can penetrate just over 4 meters of water before being annihilated. So that's about it for this video. We applied the idea of the binary particle to the photon, and there seems to be a logic to how electromagnetic radiation of different frequencies would react when contacting a solid. Your feedback on these videos is welcomed, But please offer criticism based upon logic, not dogma. If you wish to disagree with the concept of the binary particle, that's fine. But don't blindly state that the photon is massless. Where's the proof? If there are mathematicians watching, your help in either proving or disproving the binary particle concept would be much appreciated. Don't forget to like and share this video. Hit the bell icon if you want to get notified when a new video is released. Thanks for watching. See you in the next video.